This video is for November 7th, November 8th. We're looking at fundamental trig identities, things we'll use moving forward to simplify different expressions. We ended the last video proving this. Now we're going to use this to actually prove this guy. So I'm going to write this down. I'm going to use this here, sine squared plus cosine squared equals 1, because it's going to be really beneficial moving forward, especially as you prepare for your assessment over this. But we can prove this identity here from this. Namely, we have to use that tangent. If we have tangent, if we want to write that in terms of sine and cosine, well, hopefully we know. If we don't know, you're going to need to know this moving forward, that tangent is sine over cosine. And so we'll actually use this here. So we have sine and cosine. We need cosine in the denominator. I'm going to move this up so I don't get in the shadows. We need cosine in the denominator. Similar thing here. We need hypotenuse in the denominator, and we divided everything by hypotenuse. Here we would like cosine in the denominator, so maybe we divide everything by cosine squared specifically. Which we can do. Again, similar thing here. We had addition in the numerator and we split up the fraction. We have addition in the numerator. We can split up this fraction as well and write that as sine squared u over cosine squared. Equals 1 over cosine squared. And similar thing as here. We have sine divided by cosine, sine divided by cosine. They're both squared. So this would become tangent squared u. We have cosine divided by cosine. That would just be 1. Something divided by itself is 1. And here we have 1 over cosine squared. Up here we saw that, and with our reciprocal identities, that 1 over cosine was secant. So if we have 1 over cosine squared, that would actually be secant squared. So we can use a reciprocal identity here, 1 over cosine, to show that this is equal to secant squared u, which is the exact same thing we have here. Just the tangent squared plus 1. We could put that 1 there and have the exact same thing. Okay, so this is another Pythagorean identity similar to sine squared plus cosine squared equals 1. This is another identity that we can use in our tool belt. Have as a tool in our tool belt if we needed to use it to simplify expressions. If you need to pause, rewind, please feel free to do so. I'm going to move to the back side here. This is the third Pythagorean identity. I'm not going to prove it. If you want to try to prove it, I would recommend doing that. The thing you'll need to use here, and thing you'll need to know moving forward, if tangent is sine divided by cosine, then that means that cotangent would be cosine divided by sine. So you can use sine squared plus cosine squared equals 1. You want sine in the denominator here, so I'll actually let you try to see if you can figure that one out and do that. Let's move on to cofunction identities. I'm not going to go through all of it. Essentially here we have the sine parent function, that's the solid line, and the cosine parent function, that's the dotted line. And we want to figure out what transformations could be applied to put sine directly on top of cosine. And what a lot of students said is, hey, I can just move it to the left 1, 2. 2 tick marks is pi over 2. So I can move it to the left pi over 2 units. And sure, that is true. We can do that. But some students said I can move this over to the right 2 units. Or if it's 2 tick marks, so that would be pi over 2 units. And then if I move it here, what I would need to do is reflect it, and then it would be directly on top of cosine. And so what we talked about is, let's write this function. So if I have sine, if I want to move to the right pi over 2 units, then that would be x minus pi over 2, because if I'm moving to the right pi over 2, then I would subtract inside the function. If I wanted to reflect across the x-axis, the negative would be here. And if I did that, I would end up with the cosine parent function, excuse me. Now, I'm going to use the even-odd identity here. I'm going to write it over here. Because the even-odd identity says if I have a negative here, I can move it inside the function if it's a sine function. And so I'm going to move that inside. That would make the x negative, and that would make this positive. And then I'm just going to clean it up and switch these two so we don't have a leading negative, and write as pi over 2 minus x. So we move the negative inside using the even-odd identity. That negative makes this x negative, makes it pi over 2 positive, and then I just switch these, pi over 2 positive, the x negative, and so this is our co-function identity for sine. And so what that means is here, another tool that we can use to simplify, if I see sine of pi over 2 minus x, I can replace that with cosine x. If I see secant of pi over 2 minus x, I can replace that with cosecant x. If I see cosine of pi over 2 minus x, I can replace that with sine x. And you kind of hopefully get the picture here. And these are what we call the co-function identities. We might not use these too much, but they are more tools in our tool belt to help us simplify different expressions. Now, you might be asking, where are we going to use this? How is this going to be used? We're actually going to simplify expressions like these guys moving forward in the next few classes and see how we can use everything that we've developed today to simplify expressions like those.